All right, so my name is Mika Hatanpaa, and I'm coming from the Nokia mobile network side there, running the R&D that's responsible for the hardware development for the Cloud Run as well as for the Cloud Core applications that Nokia is then delivering for our customers, which are typically the telecom operators. So the topic that I will be talking about today is about the Open Edge server that Nokia has contributed originally to OCP already about 3 years ago. And the primary use case for Open Edge server in our case is actually Cloud Run. So, and how we see this as of today is that the Cloud Run certainly has become a kind of a viable option in implementing the radio access networks, so RAN as an abbreviation in this presentation here. And this means the virtualization of the radio access network functions and utilizing the standard server hardware to run the virtualized network functions. And in this presentation today, I will very briefly then cover or introduce the Cloud Run architecture and cover some of the deployment challenges, what we see, especially with the virtualized distributed unit of the Cloud Run architecture. And in the presentation, I will also briefly then open or cover how the Open Edge hardware can tackle the challenges of the varying operating environments of the distributed sites in the network. Okay, briefly first about the 5G radio access network architecture, just as a brief introduction. So we could say that the 5G RAN architecture consists of 3 different elements. So the first of all, there are the radio units, which are then communicating wirelessly with the users or user entities here, or UEs. Then we have the distributed unit, which is the kind of first part of the baseband processing. And that is then processing the real-time traffic of the coming from the radio units, and of course then also going vice versa towards the radio units and towards the end users. And then the other part of the architecture is centralized unit or central unit, which is then processing the kind of non-real-time part of the baseband traffic. Then about the kind of deployment options. There are several different deployment options of the Cloud Run. And I'll start briefly by introducing also how we actually deploy, as of today, the classical radio access networks, meaning basically the kind of purpose-built hardware that is today still mostly used to build the 5G networks. So in the classical architecture, we have 2 different models to deploy that as well. So we can deploy that in a kind of distributed run manner so that the DU and the CU functions are typically located at the radio site, so next to the radio tower or at the bottom of the radio tower. And this is always so that it's more like a kind of a combined one box that then combines the DU and the CU functions into a single entity or purpose-built appliance. And then this other model for classical RAN deployment is that we can also kind of centralize the baseband units into a far edge data center or kind of baseband hotel, which is what is it usually called. And that's a kind of then just creating more baseband capacity in a single point in the network. But this is very rarely used as of today. For the Cloud Run, all the time the architecture has been a bit different in that sense that the whole architecture has been such that it has kind of allowed the distribution of the BDU and the VCU functions in the network. And the typical model, I would say still as of today, is the distribution or is this kind of distributed Cloud Run deployment option where actually the VDU is located at the cell site in a similar way as in the classical model. But then the VCU could be then actually located quite far away from the VDU in a kind of edge data center. That could be kind of a same small data center where you also would then locate the packet core functions or of course, for example, 5G UPF function. And then the more centralized way of distributing the Cloud Run would be then to actually move the video function into a far edge data center a few tens of kilometers away from the radio site, and then you actually can pool the video capacity then to serve more than just a single radio unit or a few radio units. And the VCU still would be then on the kind of edge site or kind of regional edge site a bit further away. And then the kind of third option, how we see that this would be deployed, is a kind of a centralized Cloud Run deployment such that we would then locate the video and VCU functions into the same site in the far edge. Then we could also say briefly that of course all of these sites, so even when we talk about this distributed Cloud Run use case, they are kind of micro data centers, and they are very small ones. They could be just a few servers there, or maybe up to a few tens of servers, but not much more than that typically. So they are very small scale compared to the kind of hyperscale data centers, but still as we are using kind of standard server hardware there, it's kind of considered a data center, and we kind of consider that to be the whole network to be a kind of a network of small distributed data centers that are then managed as a one entity. Then about the challenges and kind of what is leading to this kind of deployment models, it's simply the kind of laws of physics in that sense that the latency between the radio unit and the video unit cannot be too big. So we talk about the kind of sub-millisecond latency that should be there between the RU and the DU in order to be efficiently process the traffic coming from the radio network. And typical distance between the RU and DU must be kept below 20 kilometers. And that's because of the kind of speed of light traveling in fiber. So basically, with this kind of distance, the latency or round trip latency between the RU and DU would be about 200 microseconds, and that's we cannot really tolerate much more because there is also additional delays kind of introduced by the different equipment in the network. Then that then means that the video is often actually located in reality in the radio sites or in the cell sites at the edge of the run or at the bottom of the tower. And an additional reason that's also kind of leading into this kind of a deployment model is such that many of the telecom operators actually don't have good sites for the good kind of far edge data center sites, because you would need to have a site where you actually have a fiber connection to all your radio units that are distributed all over the place there. So then going forward, so okay, what it then looks like in a bit more detail, that what this distributed Cloud Run sites would then look like, especially if they are located at the bottom of the tower, or they could be also located, for example, on rooftops. So basically a very small site, maybe with just one open edge chassis in this use case, with a few servers and potentially also a fronthaul gateway that is then able to handle the CPRI traffic, which needs to be kind of translated into an easy traffic that can then be kind of run over the standard Ethernet network. And in this case, then the outdoor conditions are quite challenging typically, of course, when we are really in the kind of outdoor deployment. So there can be varying thermal conditions because of sun or because of very low temperatures, for example, in Finland. And then it's also subject to moisture, rain, and hurricanes and whatever. And then there's also could be some kind of vibration and earthquakes, of course, in these kind of locations. And this is then normally tackled by an outdoor cabinet. So the OpenEdge server itself is not kind of outdoor deployable as such, but it can be deployed outdoor by using a small outdoor cabinet. We have as part of our kind of OCP solution this small outdoor cabinet that can then host a single OpenEdge 3U chassis inside the outdoor cabinet, and that then is basically providing a similar space as you would see in a kind of indoor type of deployments for the chassis itself, running inside the outdoor cabinet that then has kind of a air circulation inside the box only, and then the heat is actually extracted using a heat exchanger, which is on the bottom of this outdoor cabinet here. Then the other deployment model would be this more centralized Cloud Run deployment. What it would then look like is briefly described here. So there would be then multiple instances of the VDU located at the far edge data center, and then several cell sites, of course, would be then connected into this kind of pooled capacity of the VDU baseband processing in the far edge data center site. And this is more kind of cloud-like or data center-like solution with dynamic resource allocation and redundancy and serviceability. And then you typically would have indoor conditions there. However, if you talk about, for example, central office sites of the telecom operators as of today, they are not like typical data centers, but actually the conditions can be quite challenging there as well, and therefore we have to be able to support the kind of NIPS level 3 compliance with the hardware as such. And in this case, the OpenEdge then scales, or you can rack and stack as many as you need those in a standard 19-inch rack there. Then, okay, how the OpenEdge then meets the 5G challenge for these deployment models? It then starts directly from the hardware design itself. So it is thermally hardened to fulfill the NEPS level 3 requirements and the kind of thermal conditions from -5 to +55. And we can also tolerate down to, for example, -40 by using the outdoor cabinet, which then has a kind of warmer if the temperature goes too low. Then the compact form factor is also important for these deployments because okay, the far edge data centers are not like normal data centers, but they can be very limited in terms of the space and the depth of the kind of equipment needs to be quite limited, and we have selected this 430 millimeter depth for the OpenEdge, which seems to be quite commonly adopted also by other vendors for this kind of edge server type of solutions. It's fully front accessible and fully front serviceable, and as said, NEPS level 3 compliant in terms of thermal, EMC safety, fire resistance, and also seismic zone 4 compliant. So can be pretty much deployed in everywhere in the world, also in areas where you might have earthquakes. So and a single hardware management interface is provided for all of the servers in the chassis. Then very briefly, so where you can find more information is from the Nokia web pages about our solution, OpenEdge solution, and then also you can find more information through the OpenEdge, Open Compute products or marketplace web pages. Then to close the presentation, so call for action. OpenEdge is handled under the Telco project as a sub-project there. We, of course, would like to encourage everyone to participate that because it's the more the merrier, and I would say the ecosystem can certainly bring kind of value for the design and new ideas for the design. Then here's also the link to a white paper, which is describing actually the use cases, what I presented here in a much more detail. So please take a look at that if you want to have more data about the deployment options for Cloud Run. Okay, and I will close my presentation here. Thank you.